From the smallest atom to the largest explosion, nuclear energy holds a power unlike any other. A force that promises boundless energy, yet threatens unimaginable destruction. How did we get here? Join us as we journey from its scientific discovery to its profound impact on humanity. At its core, nuclear energy begins with the atom, the fundamental building block of all matter. Understanding its structure, with its nucleus and orbiting electrons, is key to unlocking its power. Nuclear fission is the process where an atom's nucleus splits, releasing an immense amount of energy. This splitting is triggered by a neutron, which then releases more neutrons to continue the reaction. In a controlled chain reaction, this process generates heat, which we harness for power. However, an uncontrolled chain reaction leads to a rapid, explosive release of energy. Einstein's famous equation, E equals mc, perfectly encapsulates this principle of mass-energy conversion. It reveals how a small amount of mass can be transformed into an enormous amount of energy. Beyond destruction, nuclear energy offers incredible promise for peaceful applications. Modern nuclear reactors are marvels of engineering, providing reliable, clean electricity. They operate with high efficiency and produce virtually no greenhouse gas emissions. Nuclear technology also revolutionizes medicine, particularly in diagnostics and treatment. PET scans use radioactive tracers to visualize internal body functions, aiding early disease detection. Radiotherapy using targeted radiation effectively combats cancer cells, saving countless lives. In agriculture, nuclear techniques help control pests and develop resilient crop varieties. Industrially, it's used for sterilization of equipment and material testing, ensuring safety and quality. EBEN. In space, radioisotope. Thermoelectric generators power spacecraft on distant missions. Yet, the same science that powers our world also harbors an unparalleled destructive force. The atomic bomb, a terrifying manifestation of uncontrolled fission, changed warfare forever. The devastation of Hiroshima and Nagasaki stands as a grim reminder of its catastrophic power. The uncontrolled chain reaction releases energy on an unimaginable scale, instantly vaporizing cities. Hydrogen bombs, or fusion bombs, possess even greater destructive potential. They're power dwarfs that have atomic bombs, threatening global annihilation. A nuclear winter scenario depicts a world plunged into darkness and cold after a global conflict. Radioactive fallout would render vast areas uninhabitable for generations, with long-term health effects. The proliferation of nuclear weapons to more countries poses an ever-present danger. This raises the risk of accidental use or regional conflicts escalating into global catastrophe. The journey of nuclear science began with brilliant minds, unraveling nature's deepest secrets. Their discoveries laid the groundwork for both energy and destruction. The Manhattan Project, a top-secret World War II initiative, accelerated the development of the atomic bomb. It culminated in the first nuclear explosion, forever altering the course of history. The Cold War ushered in an arms race, with nations stockpiling vast nuclear arsenals. The threat of mutually assured destruction, or MAD, loomed large over humanity. Major accidents like Chernobyl and Fukushima highlighted the inherent risks of nuclear power. These events underscored the critical need for stringent safety protocols and continuous oversight. Today, the global nuclear arsenal remains a complex geopolitical challenge. Efforts for disarmament and non-proliferation continue, seeking a safer world. Simultaneously, there's renewed interest in nuclear power to combat climate change. New reactor designs promise enhanced safety and efficiency, addressing past concerns. Nuclear fusion research offers the ultimate clean energy dream: limitless power from water. This could provide a safer, virtually inexhaustible energy source for future generations. Yet, profound ethical dilemmas persist. How do we wield such immense power responsibly? Nuclear energy stands as a testament to human ingenuity and our capacity for destruction. The future of nuclear energy, whether as a beacon of progress or a shadow of annihilation, rests in our hands. It is our collective responsibility to ensure this powerful technology serves humanity's best interests.